built in a lavish style, it retains an old world charm of its own even today. And this here is the very room that Chandra occupied for 27 years.
Chandra was the first theoretician in a modern sense who was appointed to the Department of Astronomy and Astrophysics, at least in the 1930s. In the United States, astronomy was really organized around observational program. The Department of Astronomy and Astrophysics was concentrated at the Yerkes Observatory.
The 40-inch achromatic refracting telescope is fitted atop a high mount and is the largest telescope ever to be used for research purposes. And the entire floor can be lifted to raise astronomers to the eyepiece and also adjust to the tilt of the telescope. The revolving dome has a circumference of over 60 feet. In addition, the observatory also houses a couple of reflecting telescopes and is situated in a 70-acre woodland. And it is here that Chandra built his house overlooking the lake, which was to be his home for the next 28 years. In 1964, Chandra shifted base from Yerkes to the main Chicago campus and started taking classes at the Laboratory for Astrophysics and Space Research. From then till the very end, he continued to occupy the corner room at the end of the corridor, overlooking the Regenstein Library, which now houses the archive of his life's work: original manuscripts, books, and letters.
After shifting to Chicago, Chandra turned his attention to a long-abandoned subject: the consequences of the limiting mass of white dwarfs. He devoted the next 30 years to a detailed investigation of black holes and singularities, covered in his book, The Mathematical Theory of Black Holes.
But when Chandra really got into it and solved that in the 80s, he was able to analyze the structure of how the black holes react to external perturbations using very beautiful and very sophisticated mathematics, and basically derive the whole theory of what is called black hole perturbations. And that is what this book is about. And it is a Bible for people who work in that area.
Chandra's intellectual talents cut across the disciplines of physics, applied mathematics, astronomy, and astrophysics. During a 6-decade-long career, Chandra's research interests spanned an incredibly wide spectrum. Commenting on this, he once said, "My work has followed a certain pattern motivated primarily by a quest after perspectives." He also said, "I work on my own for my personal satisfaction, generally outside the scientific mainstream." Chandra's work invariably had a way of becoming mainstream a few years down the line. His highly cited review of Brownian motion started new fields of research even outside astronomy. His concept of dynamical friction appears almost as often in the literature as the Chandrasekhar limit. Apart from his long list of influential research papers, Chandra was also a prolific author. His masterly treatment of radiative transfer pioneered the invariant embedding technique, which later found applications in other fields as well. One good measure of Chandra's influence on our field is that over 100,000 copies of his highly technical books have been sold. And Newton's Principia, for the common reader, published just a couple of months before his death, was a result of his deep regard and admiration for a scientist whose work he believed to be both unsurpassed and unsurpassable.
He has made many contributions to the subject. Characteristically, he puts all his research in a book after 4 or 5 years. But the contribution which he personally felt he was most happy with, not only within radiative transfer but perhaps in his entire career, concerned a very specific problem which had been unsolved from almost 1871. That was the year in which the blue of the sky was explained by the English physicist Lord Rayleigh. But that explanation was incomplete because it did not allow for one very important property of the radiation, which is technically known as polarization. So he first formulated the right equations and they looked extremely complicated, and a lesser person would have just gone to a computer. But what he did, and there he acknowledges taking a vital idea from a Russian astrophysicist called Ambartsumian, what he did was to come up with something that surprised the whole community. These very complicated looking equations, after he made various transformations on them, actually produced an exact solution. But he did not stop there. He compared it with the experimental data which had been taken on the properties of the sky, and the comparison is there in his book. So this was the kind of crowning glory of his work. And in the overall field of radiative transfer, any new person entering the field would be first asked to read his book because the basic principles have not changed. What has changed is that we now have much more powerful computers and we have much more detailed knowledge of the atomic physics, but his work still remains a landmark.
Isaac Newton's Principia, published in 1687, is one of the most important scientific books ever written, laying the groundwork for all of classical mechanics. Newton described universal gravitation and 3 laws of dynamics, which dominated our view of the universe for the next 2 centuries. In mathematics, Newton is credited with the invention of calculus and was the first to apply it to physics. Newton showed that the motion of objects on Earth and of celestial bodies were governed by the same natural laws of motion. By demonstrating consistency between Kepler's laws of planetary motion and his own theory of gravitation, Newton successfully eliminated all remaining doubts about heliocentrism.
Gravitation is, of course, extremely important, and for most problems in astrophysics up to the 1960s, Newtonian gravity was sufficient. And indeed, Chandra himself, along with one of his students, wrote a book called Ellipsoidal Figures of Equilibrium, how a fluid mass which rotates can deform in shape under the joint influence of rotation and gravity. So he was a master of Newtonian gravity, there is no doubt about that.
I think in the Chandrasekhar's style of working, he said the first word in the field of white dwarf limiting mass, and that was his really seminal contribution for which he earned the Nobel Prize. Well, good many decades after he had done the work. He got it in 1983.
Chandra's prolific contribution to diverse areas of science made him a winner of all the coveted honors, medals, and prizes. The Indian National Science Academy crowned him with the Srinivas Ramanujan Medal and the Venu Bapu Memorial Award. The Government of India took pride in bestowing on him the Padma Vibhushan. The Indian Institute of Astrophysics established the Himalayan Chandra Telescope at Hanle in Ladakh. It comprises of a 2-meter telescope equipped with a faint object spectrograph camera with optical and infrared imagers. It is operated remotely from a center at Hoskote near Bengaluru via a dedicated satellite link. Its data archive has helped many an Indian and foreign astronomer and astrophysicist.
I was involved with the setting up of IUCAA. We were at the time looking for somebody who was great enough and was an astrophysicist and was somebody who was completely unique. And there was no better person suited to that description than Chandra. And he inaugurated our IUCAA by setting the Foucault pendulum here in motion.
Galileo's invention of the simple telescope spurred the development of astronomy into an exciting discipline of science, and in the middle of the last century, propelled us into the space age. Since then, man has made a mark on the very craters of the moon, first observed using that refracting telescope in 1609. In most fields, researchers would be thrilled to have just one direct glimpse of the past. Cosmology, the study of the origin and evolution of the universe, is such a field where one may witness history. The beams of starlight we see carry photons that have been streaming towards us for many thousands of years. Thus, we are actually staring at signals of an ancient past. The original Galilean telescope gathered about 55 times more light than the unaided eye. Over the last 400 years, Galileo's simple telescope has become highly sophisticated, 1 billion times more sensitive than the naked eye. It would be no exaggeration to say that a comparable rate of sophistication has been achieved in just the past few decades with the advent of the modern-day satellite telescopes.
Chandra is the premier X-ray astronomy observatory for the NASA. And it was launched about 11 years ago, in 1999. Chandra was named after a Nobel Prize physicist, Subrahmanyan Chandrasekhar. It's very apt naming of the satellite because Chandrasekhar had many contributions to astrophysics. But one of the reasons why people remember him more is because of his work on the end products of stellar evolution: white dwarfs, neutron stars, black holes. And these are exactly the sources of X-rays that we see with the Chandra satellite. And what we see in X-rays, therefore, are things that are very, very hot. Chandra has given us beautiful information on the lifetime of a star. Star sometimes explodes. It's what we call a supernova.
The NASA Chandra X-ray Observatory serves as a metaphor for his continuing legacy, detecting X-ray sources that are billions of light years away, unraveling the deepest and darkest secrets of our universe.
In Chandra's birth centenary year, 3 important meetings took place. One in Chicago, which was his working place most of his life. The second in Bangalore, and the third in Chennai. These meetings reflect the high regard in which he was placed internationally, how he was considered an important figure in different branches of astrophysics. Because these meetings brought together under one roof people working in different areas who would not normally be seen under the same roof, but who shared the common interest that they were inspired by Chandra's work in their respective subjects.
The great rigor and insistence, you have to do it right, that characterized Chandra's approach to to physics and astrophysics.
In particular, he had a great sensitivity to mathematical equations, so he could feel his way through complicated things which the mere complication would have daunted anybody else, and he could feel his way through, largely through this aesthetic sense that he had in this area.
That was certainly the day that I realized he was not an austere authoritarian figure. He was really a very caring person.
Today, astrophysics is regarded as one of the landmarks in our understanding of the cosmos, where the rules of quantum mechanics merge or interact with the rules of laws of gravity and all other forces which act on at greater distances. So one could say that this was the legacy which Chandrasekhar left and which is being cherished by people who work in astrophysics today.
Astronomy is the only science for which we have a continuous record from ancient times to the present. It appears to have justified the curiosity that man has felt about the origin of the universe. Man's contemplation of the astronomical universe has provided us with the one continuous thread that connects us with antiquity.